Good morning everyone. Welcome to today's maths class. I hope everyone understood the properties which we have discussed in the previous class. So they are closure property, associative property, commutative property, multiplicative inverse, additive inverse, multiplicative identity and additive identity. Okay. By using those all properties, we are going to do the problems from exercise 1.1. Okay, now look at the first problem from the exercise 1.1, that is using appropriate properties find minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. Okay, here in this numerical expression there are three terms. Now look at this. The first term is this one, minus 2 by 3 into 3 by 5. Second one is 5 by 2 and third one is 3 by 5 minus 3 by 5 into 1 by 6. Among these three terms, the first and third term are having the same numerical value 3 by 5 and 3 by 5. So let us write this first part and third part side by side. Now let us write like this, minus 2 by 3 into 3 by 5. Let us write the third part after this, minus 3 by 5 into 1 by 6 and send this second part at the end, 5 by 2. Now what can you take common from the first two terms? In this, both terms are having minus, so we can take minus common. And 3 by 5 is also there in both the terms, so we can take 3 by 5 also common. Then what is left over in the first part? 2 by 3. In this minus we have taken common, so it will become plus and 1 by 6 plus 5 by 2. Clear? Now let us simplify this. Minus 3 by 5. We can simplify this bracket by using cross multiplication. 2 into 6 plus 1 into 3 by 3 into 6 plus 5 by 2. Here, now look at this. Here minus 3 by 5 into 2 6 ja 12 plus 1 3 is 3 by 3 6 ja 18 plus 5 by 2. Now we can write this as minus 3 by 5, 12 plus 3 15 by 18 plus 5 by 2. Now we can simplify like this, 5 3 is 15 and 3 6 is 18 and 3 1 is 3 2's. We will get 1 by 2. Here we have minus 1 by 2 plus 5 by 2. So minus 1 plus 5 whole by 2 can be written as 4 by 2. 4 by 2 is 2. The final answer is 2. So we can find this value. We got 2. In this procedure we have used two properties. What are those two properties? See, in this we have interchanged the first and the second and third terms. In that we have used associative property. Okay, and what is the property which we have used in this step? Here we have taken 3 by 5 common from the first two terms. Here we have used this, this step we got it by using distributive property. So by using these two properties we can find this value and we got 2. Now let us do the second problem in the first Roman. Here also we have three terms, 2 by 5 into minus 3 by 7, minus 1 by 6 into 3 by 2, plus 1 by 14 into 2 by 5. Let us write the first part and the third part, the third term side by side, and let us send the second term to last. Now let us take 2 by 5 common from the first two terms. Okay, then we get minus. Here we can cancel 3 2's. So in the numerator there is 1. Here 2 2's are 4. Okay. Now here what properties we have been using? Here we have used this step we got by using associative property. same like the previous problem. And here we have taken common 2 by from these two terms. So we have been using distributive property. Got it? Now let us simplify this. 2 by 5 minus 3 cross multiplication into 14 plus 1 into 7 by, what do you get? 7 into 14 minus 1 by 4. Now 2 by 5 into minus 3 14s minus 42 plus 7 by 7 14s 98 minus 1 by 4. 2 by 5 into minus 42 plus 7 is minus 35 by 98 minus 1 by 4. Okay, here in 7 table 7 5s and 7 14s. Again these two 5s can be cancelled and 2 1s are 2 7s. Finally we get 1 by 7 minus 1 by 4. Okay. Now by using cross multiplication, minus 1 into 4 minus 1 into 7 by 7 into 4. So let us write this final step at this corner. Minus 1 into 4 minus 4 minus 1 into 7 minus 7 by 7 into 4 28. That is equal to minus 4 minus 7 is minus 11 by 28. This is the answer. Okay. In this problem also we have been using the associative property and distributive property. Okay. Now look at the second Roman from the exercise 1.1. Write the additive inverse of the following. What is meant by additive inverse? It is very simple to write the additive inverse of any rational number. Just we need to change its symbol. If the given number is having minus, we need to take with plus. Okay, if it is having plus, its additive inverse is the same number with opposite symbol minus. Okay, now like that we can write very in a simple way like this. Additive inverse of 2 by 8, simply we can write minus 2 by 8. Why? Because the given fraction 2 by 8 is having no symbol, means it has plus. So we have to take its negative symbol. Its additive inverse is minus 2 by 8. Like that, the additive inverse of minus 5 by 9 is plus 5 by 9. It is not necessary to put the symbol plus. Why? Because if there is nothing, the symbol, we can treat it as plus. Now, additive inverse of minus 6 by minus 5. Actually, minus 6 by minus 5. Both the numerator and denominator are having minus. Okay. If your fraction is having two minuses, by multiplying those two, we get plus. So, indirectly, it is given 6 by 5. Okay. 6 by 5. What is the additive inverse of 6 by 5? Minus 6 by 5. Therefore, the additive inverse of minus 6 by minus 5 is minus 6 by 5. Now look at the fourth problem. Additive inverse of 2 by minus 9. Here the symbol minus is there for the denominator. Wherever the minus is there for a fraction, whether it is in the numerator or denominator or at the middle of the fraction, the minus will belong to the whole, the value given rational number. So we can write its negative. So its additive inverse as 2 by plus 9. That is 2 by 9. Okay. Like that, the additive inverse of 19 by minus 6 is 19 by 6. Got it? So it is very simple to write the additive inverse of any rational number. Just we have to change its symbol. Okay. Now the third problem. Verify that minus of minus x is equal to x. Now look at this. The first one, x is given as 11 by 15. Now let us take the LHS. LHS minus of minus x. This is equal to minus of minus. What is the x value? The given x value is 11 by 15. Let us substitute 11 by 15 in the place of x. Then we get minus to minus plus 11 by 15. It is given that 11 by 15 is x. So we get x. Okay. Therefore, this is RHS. Therefore, LHS is equal to RHS. Okay. Now the second one, x is given as minus 13 by 17. Here also let us take the LHS. What is the LHS? Minus of minus x. This is equal to minus of minus. What is the x value? The x value is given as minus 13 by 17. So these two minuses are there in the LHS, and this x is also having one minus. Totally there are three minuses. So we will get minus to minus plus minus 13 by 17. Okay, these two minus will become plus, and there will be one more minus left over. So minus 13 by 17. So as for the given problem, what is x? Minus 13 by 17. So we can take it as x. Therefore this is RHS. Therefore we get LHS is equal to RHS. So in both the problems we have proved minus of minus x is equal to x. Okay. Now in this fourth Roman we need to find the multiplicative inverse of the given rational numbers. What is meant by multiplicative inverse? We have discussed in the previous class already. The multiplicative inverse of a rational number is nothing but its reciprocal. So we need to interchange the numerator and denominator of the given rational number. See, look at this. Here the multiplicative inverse of minus 13 is simply we have to write minus 1 by 13. So we should not change the symbol in this multiplicative inverse. While we are doing the additive inverse in the second Roman, we have changed only the symbol without changing the numbers. Okay, here without changing the symbol, we have to take the reciprocal of the given rational number. Now, the multiplicative inverse of minus 13 by 19 is minus 19 by 13. Just reverse it. And the multiplicative inverse of 1 by 5 is 5 by 1. 5 by 1 means simply we can write it as 5. Okay, and the multiplicative inverse of minus 5 by 8 into minus 3 by 7. Actually, look in the rough work. See, minus 5 by 8 into minus 3 by 7 means here minus into minus plus 5 3 is a 15 by 8 7 is 56. The product of this given value is 15 by 56. What is the multiplicative inverse of this 15 by 56? We have to take its reciprocal, that is 56 by 15. Okay, so let us do the remaining two sums, 5th and 6th also. Here see, let us do 5th and 6th here. The 5th one is the multiplicative inverse of, what is the given number? Minus 1 into minus 2 by 5. Okay, look at the rough work. Minus 1 into minus 2 by 5. Minus to minus plus 1 into 2 by 5. So the value of this expression is 2 by 5. What is the multiplicative inverse of 2 by 5? It's reciprocal. What is its reciprocal? Just we have to reverse it. Means 5 by 2. Okay. And the 6th one, multiplicative inverse of, what is that? Minus 1. The minus 1 means its reciprocal will be minus 1 by 1 actually. So minus 1 can be written as minus 1 by 1. If you take the reciprocal of minus 1 by 1, again you will get minus 1 by 1 only. Okay, there is no change in the reciprocal. So the multiplicative inverse of minus 1 is again minus 1. Understood? Now the 5th Roman, name the property in the following. Now look at this. Minus 4 by 5 into 1 is equal to 1 into minus 4 by 5 is equal to minus 4 by 5. For example, if you have taken 8 and multiplied with 1, you will get 8 again. There will be no change of 8 if you multiply with 1. In the same way, if 1 multiplies with 8, the product will be 8. So whether we multiply 8 with 1, otherwise 1 is multiplied with however it is, you will get the same value again. There will be no change in multiplication with 1. So 1 is called the multiplicative identity. In this one is the multiplicative identity. So in the first part, in the first problem, the multiplicative identity property has been involved. Now look at this. In this one, minus 13 by 17 into minus 2 by 7 is equal to minus 2 by 7 into minus 13 by 17. Now let us recall the definition or property of rational numbers. A into B is equal to B into A. For any two rational numbers, A and B, if you multiply A and B and A, you will get the same value. That is called the commutative property. So, this is commutative property. Under what is the operation involved in this? Multiplication. Got it? Now, look at this. Here, minus 19 by 29 into 29 by minus 19 is 1. So, why did we get like this? Just we have discussed in the fourth Roman that the multiplicative inverse. Okay. So, what is the multiplicative inverse? If you multiply 2 by 8 or 2 by 7 and its reciprocal 7 by 2, by cancelling 7, 7, 2, 2 in the numerator and denominator, you will get 1. So whenever you multiply a rational number with its reciprocal, you will get 1. 1 is the multiplicative identity. You will get multiplicative identity by multiplying a number with its reciprocal. That property is called multiplicative inverse. So property of multiplicative inverse. Okay. Now look at the sixth problem. Here we need to multiply 6 by 13 by the reciprocal of minus 7 by 16. Okay. As per the given problem, the 6 by 13 should be multiplied with the reciprocal of minus 7 by 16 is equal to 6 by 13 into what is the reciprocal of minus 7 by 16? Without changing the symbol, we have to interchange the numerator and denominator, then we get like this. So here there is no symbol before 6 by 13, so it is plus. Plus into minus is minus. Now 6 into 16 can be written as 96 by 91. Okay. Now the value is minus 96 by 91. So when you multiply 6 by 13 with the reciprocal of minus 7 by 16, we get minus 96 by 91. So here what is the property allows you to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. So let us recall the property which we have learned already. A into B into C is equal to A into B into C. What is this property? Associative property. Associative property under multiplication. Why? Because here we have used the basic operation into multiplication. So this property can be used to compute this as this one. Therefore the answer is associative property. Under multiplication. Okay. So the eighth problem is 8 by 9 is the multiplicative inverse of minus 1 by 8. We need to check it. Actually, whenever you multiply a number with its multiplicative inverse, you must get 1. Why? Because 1 is the multiplicative identity. So if 8 by 9 is the multiplicative inverse of minus 1 1 by 8. We must get 1 when we multiply these two. Okay, let us check whether we get 1 or not. If we get 1, we can say that it is multiplicative inverse, otherwise it is not. Okay, now multiply 8 by 9 into minus 1 by 8. This is called 8 by 9 into minus 8 1 1 plus 1 9 by 8. Now in the numerator and denominator we can cancel 9 1 9, 8 1 8. So we get, here there is nothing here, plus into minus 1 into 1 1. Okay, here we did not get 1. We must get 1 to decide whether the given number is multiplicative inverse or not. As we didn't get 1, we can say that 8 by 9 is not the multiplicative inverse. Okay, since 8 by 9 into minus 1 by 8 is not equal to 1. This is the reason. In the same way, we can check whether 0.3 is the multiplicative inverse of 1 by 3 or not. Let us multiply these two. 0.3 into 1 by 3. So what is 0.3? So after the decimal point there is one number. So we can write 3 by 10 into 1 by 3 mixed fraction, convert into improper fraction. Then we get 3 1 3 plus 1, 4 by 3. We can cancel 3. Okay. 0.3 can be written as 3 by 10 and 3 1 3 plus 1, 4 by 3. Okay. Now how can you write it? Sorry, the given problem is not 1 by 3, 3 1 by 3. So let us multiply 0.3 into 3 1 by 3. Now 0.3 can be written as 3 by 10 and 3 1 by 3 is 3 3 is 9 plus 1, 10 by 3. Now we can cancel 10 in the numerator and denominator, and 3 1 3. 1 into 1, 1. The product is 1. Then what can you say? Therefore 0.3 is the multiplicative inverse of 3 1 by 3. Since why? Since 0.3 into 3 1 by 3 is equal to 1. Okay. Now let us answer the one word answer questions given in the 10th Roman. The first one, 10th Roman first one. The rational number that does not have a reciprocal. The answer is 0. Okay, 0 has no reciprocal. Why? Because if you write 0 as 1 by 0, so 0 should not be in the denominator. Why? Because 1 by 0 does not exist. Okay, something by 0 never be defined. So 0 has no reciprocal. That is the answer for the 10th Roman first one. And the rational number that are equal to the reciprocals. There are two answers. One is 1 and minus 1. Why? Because the reciprocal or the multiplicative inverse of 1 is 1 by 1. Again you will get 1. Like that, the multiplicative inverse or reciprocal of minus 1 is also again minus 1. So the multiplicative inverse or the reciprocals are equal to again to themselves for 1 and minus 1. What is the rational number that is equal to its negative? The answer is 0. Why? Because 0 is neither positive nor negative. Now look at the 11th Roman, the first one. 0 has dash reciprocal. There is no reciprocal for 0. So the answer is no, there is no reciprocal. The numbers dash and dash are their own reciprocals. As we discussed in the 10th Roman second one, the answer is 10 and minus 1. Okay. The third Roman. The reciprocal of minus 5 is 1 by minus 5. Okay. The fourth one. Reciprocal of 1 by x, where x is not equal to 0, simply we can write as x Okay, look at the 5th and 6th bits from the 11th Roman. The product of two rational numbers is always a rational number again. Okay. Next, the reciprocal of a positive rational number is always positive. Answer is positive. Okay. So by this we have completed the exercise 1.1. So we will continue the exercise 1.2 in the next class. Okay, thank you. Have a nice day.